All right, welcome to this week's video. We'll have two videos this week, and on the screen here is kind of an overview. So there's one really big, important new subject, and that's the user-defined functions. So you guys know what a function is, right? They're kind of the same as Excel. A function has a name, it has some input values, and has a result. The print function is actually the print command we've been using is actually a function because it has both input and output, kind of like that. Um, but a user-defined function is when we get to design our own function. We give it its own name to do something we might want to do over and over again, right? Maybe it's a complicated finance calculation, and you're in the banking business, and once you get that equation working correctly, you put it in a function, you kind of don't have to, you can use it over and over and not look at it. So that's the big thing. But then I got kind of a bunch of small things that I kind of want to point out as well. So let's go through that. And the first of those is the PEP 8 coding standards. PEP 8 coding standards. So I haven't mentioned this yet, but PEP 8 coding standards are the way you should type your code. They are not absolutely required for making Python work. So Python will work if you ignore this, but in a organizational setting, other people are going to have to read your code. And in fact, you're going to have to read your code maybe, a month after you wrote it, and it'll be hard to read. These PEP 8 standards really make your code a lot easier to read, debug, look for mistakes, and things like that. They're fairly simple. There's a link here to the full guide, and so I'll only point out some of the key ones. And really, the first really important one is the spacing. Look how this line of code here is written x equals 2 times 3. There's a space on each side of an equal sign, and there's a space on each side of an operator. So that's a standard, and it's recommended not to do it, this second example, without the spaces. And I think you can see it's really clearer to read, easier to read down the page. Variable and function names should be in what's called snake case. Snake case means each word is lowercase, and between the words is an underscore. So all variable names and all function names should be in snake case in Python. Classes, we haven't got the classes. Classes come in next week, but classes should be in camel case. Camel case means each word has a capital letter, and the words are just put together and they don't have an underscore between them. So this is camel case. That's how we'll name classes. We're going to learn about classes next week. And indentation should be 4 spaces. Okay, so we said a block of text, like in an if or a while or something like that, must be indented so that Python knows that it's a block of text that fits under that higher construct. So, if it's an if, what are the things you do if that if is true? It's a set of lines that are indented the same way. Python allows you to indent at different levels. The recommendation is to always use 4 spaces, and this is a good way to do it. The tab key on your keyboard, what happens when you press the tab key depends on the software you're using. If you're using a Python editor, that tab will usually insert 4 spaces, not the tab character like it does in Microsoft Word, for example. So in the Colab editor that we're in here, you can go to Tools, Settings, and Editor, and it will set how many space characters are inserted when you hit the tab key with the default setting. And you should set that to 4. I think it starts out as 2. Never actually use the tab character, but again, when you push the tab character in Colab, it inserts 4 spaces. It does not insert a tab character. The tab character does sometimes get in the way if you're cutting and pasting from something like Microsoft Word and there happen to be tab characters in that and you pasted that into Colab, you would get an error message because Python doesn't know what to do with the tab character. Limit all lines to 79 characters. So super long lines that go like way off the page and you have to scroll back and forth. hard to read. So all lines can be continued down on the next line if you need them to be more than 79 characters. Surround top level functions and class definitions with 2 blank lines. All right. All right. And so if you want to read these in detail and do a little bit more, but the things I've put here are basically enough for this class. Line numbers. So if you notice my Colab list in this section of text, I list 5 line numbers. And so and the error message will tell you what line the error is in. So it's good to do that. These can be turned on and off in Tools Setting Editor also. So I recommend turn those on because often the error messages say error in line 3 or whatever, and then you can just see the line number. So just an editor thing. Let's see. Good. Okay, that's line numbers. Don't assign keywords as variables, right? So we know a keyword means like a word that Python already uses for something. So we've used print as a function to, we've used it kind of like line 5 there, print stuff, right? If we use that word as a variable, look at this line 4, print equals 6. Well, that's not using the print function properly. It's using the word print as a variable name and assigning it the value 6. This is kind of a weird thing because Python will actually allow you to do it. When I execute line 4, I will have a variable named print, and it will hold the value 6, and I'll be able to use that variable all I want, no problem. The problem is now Python will not be able to find the print function. When I call the print function, that word has been reassigned as a variable, and in this case, set equals to 6, and that's what makes this error message. Int means integer object. So print, having been assigned to 6, is now an integer object, and so you couldn't use that like a function anymore. So that's when I run this, I get that error message, and down here, there is a function or a command called delete for deleting variables. And if I delete print, that deletes that copy that is the word print. And then the print function comes back to life. And see, my print stuff works again. But basically, just don't do that, right? You wouldn't use it as a variable, then later delete it, and then start using it again. You wouldn't really do any of this. So you would just avoid using those words. And so any word you know is a word in Python, try to avoid. Let's see. This just points out a little bit of a shorthand. If we do x equals x plus 1, right, that means first calculate x plus 1. So x equals 1, we take 1 plus 1 is 2, and then we take that 2 and put it into that same variable x. So on the right of the equal sign, it's like the old value x because we're going to use it. But when we figure out everything on the right side, then we store it back in the left side. So we can use the variable name of both sides. Because like +1 or +2 or something happens so often, they make this little shorthand. We can use x plus equal 1 is exactly equivalent to x equals x plus 1, a little shorthand in the notation. It's kind of just they decided to throw that in there because there's so many little counters that you tend to use in programming. So they make that shorthand. And something like that, it doesn't even matter really to me in your homework if you use that or not. It's just up to you. But it's the more you know, the better. Here in this example, this is we got the while loop here and the for loop here, and I'm using them for just as a comparison, right? It's a comparison. There are cases where you can use the same thing. So I would say this example, I would probably say the for loop is a little better, but I just wanted to give you an example saying sometimes if we're just, doing something 10 times or whatever, both of these methods, the while and the for, can be used interchangeably. So notice how they both work. Uh, I would say um, the for loop is probably better in this example, right? It's a little bit shorter. For my number in is kind of a natural thing to have a number go through an iterable object like that. And the while is usually this condition is something a little bit more complicated. So just a comparison of that. Now here's something also wanted to look at is the while loop being used to test your input. So whenever you can, you remember we're asking our user questions. They type something in. The data type of what they typed in always starts out as text. And then we tend to want to convert it. Sometimes we have to convert it. Sometimes we want text. Sometimes we don't. Um, what happens if the user types something in that's not valid and we can't even use it in our code? So that's a little bit of a problem. So here's an example where I know I need to get an integer from the user. And if I don't get an integer, my code won't work. So what I've done is this while loop, while not quantity is digit. All right, so there's a couple things going on there, right? So quantity is is a variable that I set up, and it's where the result of what the user types in, right? How many oranges do you like? Type in something that goes into quantity, right? The data type of quantity is text, and it may or may not have the number or a number in it, because the user might not have done what they're supposed to do. So when we take the is digit method, okay, I'm using the word method and function. If you're a computer science major, sometimes they make you use those correctly. But in this class, it's essentially the same thing as a function, but it has a little bit different notation, right? Quantity is a variable name. Dot meaning this is a function that's going to act on that variable. So is digit is the function name, and it has no inputs. The reason it has no inputs because it does have the variable itself is an input, and there's no additional inputs. So with methods, you'll see sometimes there's no inputs, but it does in fact use the initial variable. So a string variable can have a function is digit. The is digit function returns true um, if you have if it's a text string that can be converted to an integer is what it's doing. So quantity is still an integer. I mean, it's still a string, but is digit is a function that says can that string be returned as an integer, and if it can, it says it's true, right? So if this value is true, that's great. That means what they typed in works. If what they typed in it works, we're gonna skip this section of code, right? The code in the while is what we do if it does not work. So if the is digit function returns true, we don't want to do the while. So the way the while works is we'll have to make that not true. Okay. And if it's while this is not true, then we need to ask the question again and see how the while loop works. Prints a message says the value is not an integer. Please re-enter. It does quantity input. How many oranges would you like? And right, this is the block of code. And in fact, this block of code is not doing the PEP8 of using 4 characters. You'll see, I'll put the 4 characters in there. Yeah, and then when it does have an integer, it will print out. So, right, so, if I put in G, is digit will be false, not is digit will be true, so the while loop will kick off, and I'll go here, as long as I put in nonsense, but I'll put in a 4, and then I'll go, hey, that's good. All right, so that's, as much as we can, we want to double check unknown things. If we're reading something for a file, somebody's typing it in, there's a chance it could be wrong. As often as we can, we want to check that because it can run in For example, so this integer function I used here, the integer function converted quantity from string to integer, but the integer function fails if it can't give an answer. So I would get an error message here. So I want to know, before I call the integer function, I want to call the isDigit function to see if the value in quantity is valid for the integer function, or the integer function is going to give me an error message. And so lots of little times that's going to sneak up on us. All right. As another example of that, I'll post this and you can look at that. But let's move on to functions. So now a function is like, calculate 3 times 5 or something like that. I don't know. We can make any kind of function we want. Find the amount of money we would have if we put it in a bank account at a certain interest rate, present value functions, things like that. So if there's a function that our business maybe uses a lot, we might want to code it as a function, and then we can call it by name and use that code over and over again. Makes it convenient. We're always kind of thinking about the structure of our code in a way that can be used over and over. Because in a business setting, you'll have chunks of code that you need to use. Once you write it once, you say, hey, that's great. Or, somebody else in the organization maybe wrote a piece of code that you guys use a lot, and then you would use that. So functions is one way to do that. Classes that we see next week will be a second way of doing that. All right, so let's look at what we got here. Basically, a user-defined function. These are comments. DEF. DEF is, and this is, I'm going to put in the 4 things here. DEF means define function. So that's a key word in Python. It says define function. The word right after it, print greeting, is what I named the function. And then in parentheses are the variables that are the inputs or arguments to that function. Okay, so we got response is my variable, equal to input. So my function writes a greeting based on somebody giving it a name as an input. So you give it a name as an input, and then this thing creates a response with the name inserted in it, and then it returns the response. So return, what, a lot of times when we use a function, right, we put like x equals the function, right? So return is the value that'll get sent back to the x. Okay, so I'll go through the call to the function here in a minute, but this is the definition of a function. Remember, Python goes sequentially down your script, right? One line at a time, right? These were just comments. When it hits the define function, all that happens is Python knows the word print greeting is a function name that you may call. If you don't call or use that function, this line of code will never get executed and doesn't do anything. So all the way up to line 10, nothing has really happened. We defined the function. Python knows the word print greeting. That's available. Nothing else is available. None of this stuff has actually happened. So let's look into the main body of code and see what's happening. So I've got a variable username. I set it equal to a string, Ken. I print that out. And that's just printing it out to see if I did it. Print. And good, I can answer it there. So I printed out the name. That's just the word Ken. That was just a reminder that I had it. And then here I do the person's response is, look at this, line 15 is where this stuff happens. The person's response is print greeting username. So print greeting is the name of my function. Now I've called it. Here's the important thing to know. The variable username, right, which is a string with Ken in it, gets copied into the variable name. So within my function, I cannot access the variable username. The variables in your main program and the variables inside your function are kept separate on purpose. And that allows you to cut and paste functions between code without a problem. Without those names could be the same, they could be different, and they'll still work. But remember, a copy is happening. So username gets copied into name. That variable name can be used in the function. It's used here to make a custom greeting. The custom greeting is made with the input function. So the result that somebody types in goes in the variable response. That variable response has what that person typed in. That variable response is also not available to the main program. We have to return response. Return response means response will go in here and replace the function call, right? Just like it does in Excel. You equal present value, you put some arguments in there, right? But you see the answer in the cell, right? So the same thing happens here. You call a function. This, when it gets evaluated, all of this gets replaced with the answer. The answer is what the person typed into response. That goes into the variable person's response, and then we printed that out. The good I typed in here ends up being down there. Okay, so that's a function. You can have any with one input argument and one response, or one return value. Okay, but you can have any number of variables. So let's go into some more examples and see how this plays out. Function to convert from Fahrenheit to Celsius. We define the function F to C. That's the name of the function. The input is degrees in Fahrenheit. And then we say cell degrees equals Fahrenheit degrees minus 32 times 5/9. And the return value is cell degrees. And here's how I use it in a print statement, right? I print 75 degrees Fahrenheit is, and then, right, remember my commas, F to C, I call the function, but this number gets replaced by the answer, which was cell degrees, and that's why this prints out here. All right. Let's continue on. Fahrenheit, Celsius, that's all fine. It's kind of the same thing. All right, functions with positional arguments. So what we just saw was a function with a positional argument, but it only had one argument. So, you couldn't really see the positional. Here's a function, divide and round. It takes a numerator, divides it by a denominator, and rounds it to however many decimal points you want. So the function name is divide and round. It's defined here. It has 3 inputs to the function. What you see below it is called a doc string. A doc, right? So 3 characters, three double quotes. Well, it works with 3 single quotes too. So 3 quotes means we're making a string, multi-line string, so it ends way down here at the other 3 quotes. But that string is not assigned to it. It's like a string because it's in quotes, but it's not assigned to anything. It doesn't say X equals all that stuff, right? And so a string that's not assigned to a variable is nothing you can use in your program. It's another way of doing documentation, right? So we think of this as a way of documentation, and the doc string is often used to define functions. And it allows, like, if you had automated software to catalog your library of functions, the automated software would know to read this doc string. For now, think of it as comments, like the pound signs were. All right, so this function has 3 inputs. They're called positional. Why? Because when we call it, we need to call it with the numbers in that order, right? Or it wouldn't know which number to line up with which. So, right? So down here it says my rounded quotient. Divide and round. It's the name of the function. So this is going to do 7 divided by 3 rounded to 4 digits, right? And the 7 gets copied to numerator. The 3 gets copied to denominator. 4 gets copied to round number. That's why we call it positional arguments. And the position is really important there. Um, and you can see the calculation inside the indentation, the colon, the indentation for a block of code that's inside the function is the same as blocks of code we've seen before that would be after an if or in a while or something like that. Inside the function, there's a variable answer. The calculation is completed, and we return answer. Return answer means this place where we called the function gets replaced with the answer. That's stored in the main program variable my rounded quotient, and it's printed out. Okay, positional arguments. You can have any number of them. When you put them in, you have to put them in order, or they'll go in the wrong variable. Sometimes you might want a default function, a default argument, right? So here, example 2, same function, divide and round, blah, blah, blah. But look at this. The third argument, round num equals 2. What that means is the value 2 is a default value. And if you skip it when you call a function, it'll use 2. And if you put it in, it'll override it and use your new one. So here's 2 different calls. If you write your function with a default value, that means it's optional whether you put the third value in. And see, I can call it in 2 different ways, right? Divide and round 7, 3. In the first example, I ignored the third argument, so it's going to use the default 2, and it printed out the 2.33. In my second example, I put in a 4. I use that. So the 4 gets copied a round number and the 2 just gets ignored. So it doesn't use the default value. And that's where you get the 2 different answers. So default arguments can be used with your positional arguments. However, you can get a little bit fancier and name the arguments in the function call. So look at this example. Same function, right? But I have 2 default values. The denominator equals 3 and round number equals 2, right? So if I just put in the first number and don't put in the next 2, then, right, I'll use the default values. If I put in 2 numbers, the first will go in numerator, the second go in denominator, and the third will go in round number. What if I want to put in a number for the first one and the third one and use the default value of the denominator? That's where I can name it when I call it, right? So my rounded quotient, divide around, line 16, I just put a 7 in. That means 7 gets copied to numerator, denominator is 3, round number is 2. Second call, look at this one. 7 is the first parameter, and the second one I named. So 7 gets copied to the numerator is first. But then round number, I named it. The 4 gets copied into round number, and I can use the 3 default. So it's going to use, this is going to be 7, 3, and 4 will be the input to that. If I put the 4 here and I don't name it, we're back to going just in order and the 4 goes into denominator. So naming the argument lets you use default values of previous arguments. If you don't have a default value, there isn't really any reason to use this. So it's when you have multiple default values and you want to replace some of the later ones and use some of the earlier ones in that list. So named arguments in the function call. And then this is kind of a little miscellaneous thing that's a little bit weird. And so I'll just kind of throw it in there. It doesn't have a real great thing. And it's called the try structure. And the try structure allows you to do something that might not work. Let me tell you, this is a method of last resort, right? Because when we were getting input and we needed an integer, we knew a way to exactly do that. No matter what somebody types, we use that isDigit function to tell if we had an integer. If we did, we carried on. If we didn't, we said no and looped again. So what the person typed in couldn't crash our program because we knew how to check for what we needed. So that's the problem. The try structure is a situation where you don't know of a good way to test, but what happens, and it could be user input, or sometimes it's when we're retrieving data across the internet, because then multiple things could happen. Things could time out, or if we're reading a file and it's the wrong format and things like that. So the try thing, there's a lot of places we'll see it. We'll see it again when we start using, accessing the internet and files and things like that. So this is a simple example, but it basically means you try a block of code, and if it does not work, you do this. Okay. And I've put the try inside a while loop, right? So while that means we're going to try and try again, and this is going to keep going, right? So I'm looking for a floating point number. I'll set is float equal to false because I don't have one in the beginning. And then I'm going to loop while I don't have a floating point number, while not is float. So the while loop itself is setting us up to basically run forever. And the key is somewhere in the while loop, you need to change is float to true to get us out of the while loop, right? So we try to ask the user for a number, enter a floating point number, and we convert it to a floating point number using the float function. The float conversion function might fail. That's the thing that could fail in this, right? If it fails, we go to the except and say it's an invalid input. And then the while loop will be all done. So we'll have to go back to while not is float and keep circulating. However, if the user typed in a number that correctly, if it does not crash when we call the float function, then the line of code directly after it gets executed, and that line of code is the is float equals true. So basically, is float equals true only gets executed if the user input line 9 does not fail. And that's what we're looking for. If line 9 does not fail, we can say, aha, the float function worked. Aha, we've got a true, and then we can stop looping. We drop out of the while and then print the value you entered here. Okay, so you see how that works. Try is going to crash. The lines after the place of the line we think that's going to crash is this line 9. If it does crash, any lines of code after line 9 within that block of try code will not execute. So, the is float is basically saying, hey, line 9 worked correctly. If it doesn't, we're going to tell the user, hey, what you entered was not a floating point number. The is float remains false. The loop goes around again. All right. And then so, what we're testing for could be completely different than this. It could be reading a file is not found. There's some different things. I tend to call this a method of last resort, in the sense that if we knew how to test for something without using the try and accept thing, then go ahead and do it. But if you're like reading a file across the internet, there's a whole bunch of things that could go wrong, and maybe you don't want to plan. You just say, if I read the file, good, and if not, forget it. I didn't. So, yeah, so that's good for this video. We get some more stuff in video B.